Hello everyone, this is Rajiv Ranjan, student of a course Tech Computer Science and Engineering from Bennett University, and with the help of this video I am going to uh, present a tutorial on SVM, the LibSVM, the support vector machine. So LibSVM is an essential part of machine learning for classification. Actually, we have various classifications methods and libraries, but SVM are one of the most classification method in machine learning. So today we are going to discuss SVM, the support vector machine. So first I would like to give introduction of library SVM, that what is library SVM. So library SVM. So library SVM is nothing, it is just an integrated software. It is an integrated software for support vector classifications, and actually it support multi-class classifications. We can use it for multi-class classification. Now the LibSVM provides a simple interface where users can easily link it with their own programs. After that, library SVM has many features. So some of them are the features that library SVM imposes. Main features. What is the features of library SVM? We can say the first one as a different SVM formulation. So different SVM formulations can be provided by the library software vector machines. The second features of SVM, library SVM, can be it is very much efficient. It is very much efficient multi-class classifications. Multi-class classification, which I have mentioned here. Multi-class classifications. The third feature of library SVM can be cross validations. It can also imposes features of cross validations for model selection. Now the fourth features can be as like probability estimate. It can best estimate the probabilities for the prediction. So the probability estimates. And the fifth main features of library SVM would be it also uses various types of kernels. The next is weighted SVM. For unbalanced data. And the seventh is it can be used when we have both in C++ and also for Java language sources, so it is compatible with this both languages. And the next, obviously it will give GUI demonstrations, GUI SVM classification, uh, and regression also, and regression. So I think these these are the main features for the library software vector machines, and we can download the latest version of library SVM software from the trusted source, and we can implement the classifications process in different scenario. So first of all, I would like to discuss that what is basically SVM, what is the meaning of support vector machine, and how does support vector machine works. So what is SVM? Support vector machine. So we can say that support vector machine generally classifies the two different objects with one classifier, or we can say the decision boundary, or one particular line that can classify the two different objects having their distinguished features. Let's take an example. Um, let's take a scenario of a beach, like here is a beach, and here is the coast of beach, and this is water, so we can mention as a sea, like this is water, this is beach, the land area. So in sea there are numerous boats and ships which are floating on the water. They can be various ships and the steamers, and likewise on the beach area there can be houses, right? People used to stay here. So we can say that this houses which is located at beach is of class C1, and the boats and ships or steamers in the oceans belongs to class C2. Now at this situation, the coastline, so this is the coastline of the beach. Actually this line separates the beach area, the land area, from the water area, and it can be said that this coastline classifies the two different objects, that these two objects are different features, right? So this is the simple example how does the support vector machine used. So in different cases we have to establish this linear separable line which can best separate the two objects which has its different features. There are lots of examples for SVM classifications, like it is used in medical areas to diagnose the cancer patients, and 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 likewise there are many other applications of SVM where linear separability is used as a SVM support vector machines. So in geometrical language we can represent the SVM like if this is a graph, this is one object of similar class, that is C1, and here is another object of different category which is C2. So now as like in this example, this coastline actually separated these two objects. So here also we can actually classify these two classes C1 and C2 with linear separable line. So it can be like this, it can be like this. This is also classifying the two class, this line also classifying the two class. We can also put the line like this, we can also put the separable line like this, and this or this or this. So in this particular area there might be a various linear straight line that can classify the two objects, but the situation is we have to take the best separable straight line, the straight line which can best suitable for the classification for these two objects. So for x1 and x2 two-dimensional space, so what will be the suitable or best fitted straight line that can classify the two different objects? So just discuss something for this issue. So we can draw again a graph of two-dimensional space like this. x1 and x2 is a two-dimensional space, and again there is a class 1 object like this, and here also another class objects like this. So the plus sign belongs to C1 class and the circle belongs to C2 class. Now we can separate it by different lines. The first case, we can separate these two classes by the straight line which is near to the class C1. The difference between this feature vector with the line is very close, but the distance between the linear separable of this line from this circle is very far. So these separability, the line of separability actually taking a favor of class C1. So this cannot be a best fitted separable line. So as likewise we can also put another line here which is near to class C2 to balancing the actual scenario. But again for for this line of separability, this feature vector is close to this line, but the feature vector of C1 class is get far from this line. So this will actually taking the favor of class C2. So what we have to do is we can draw a line like in between this, like in just between these two lines. Okay, from where this is the most closest feature vector of two different classes, and from this line, which will be the final line of separability, the distance from here to here and distance from here to here would be same. So in this scenario, this line actually is the desirable line, which best classify the two classes C1 and C2 in two-dimensional space x1 and x2. So how we will achieve this line, the decision boundary we can say, or line of separability, and what would be the scenario if the d-dimensional situations occur for more than two-dimensional, like 3, 4, 5, 6. So how can we separate the objects or classes when the linear separation is not possible? So we will discuss it now. So for the two-class problem, if we have to separate the classes, the two class, we have to separate two class. The first one is C1 and the second one is C2, and if the scenario is for 2D space, in 2D space we have to classify the class C1 and C2. So in this case we have to take a linear discriminant function, linear discriminant function as it is denoted by G of x equals to W transpose x plus B, which actually denote the straight line, the line which separate the two classes. So it can be represented by linear discriminant function G of x equals to W transpose x plus B from this equation. Now it can be also written as G of x equals to W transpose x plus W naught for 2D space. Now in these two equations, what is x and what is this W? So x is the input feature vector, feature vector. Like input feature vector can be of class C1s. These are the input feature vector, and it can be of class C2. So these are the input feature vector which can be denoted by X. Now what is W? So W is the weight vector. The weight vector. Weight vector of these input vectors. And the last, what is B in this equation, and what is W naught? No, W naught is actually placed in the place of B. So what is B or W naught? So B or W naught is the bias. Is a bias. So what is actually a bias? Bias is like this is a straight line. This straight line which is separating the two classes, the objects of two classes. So what would be the location of this straight line, right? What would be the locations of this equation, this straight line in this graph? So this bias actually calculate the distance or the locations of this straight line here, separate the two class. So we need bias as a B or W naught. Well, so this equation is for 2D space. Now if there is a 3D plane, then the linear discriminant function g of x equals to w transpose x plus b can be written as, for 3D plane it can be written as like just g of x equals to omega transpose x plus b, just equals to 0. Then it will be the linear discriminant function in 3D plane, and we know what is w, what is x, and what is b. So in 2D plane this equation is basically a straight line, but in 3D plane these equations represent a type of plane. So in 3D area, the two classes are separated by a plane in 3D plane, right? And if we use more than a three-dimensional plane, so then in place of plane we use hyperplane for more than three-dimensional space. The equation will represent the hyperplane, and hyperplane will classify the two class. Now we understand that W is actually represent the orientation of the hyperplane in d-dimensional plane, and B is the position of hyperplane in d-dimensional space. It can be also known as the bias term is biasing. We can known it as a biasing. Now for classification, for every feature vector x, I have to compute for every feature vector x, this one. So for every feature vector x we have to compute g of x equals to w transpose x plus b. Now if the value of this equations lies on positive side means the upper side, if the value lies on positive side, then g of x g of x equals to w transpose plus b would be greater than 0, then the value lies on positive side. If the value lies on the negative side, then what happen? This equation become less than 0. G of x equals to w transpose plus b becomes less than 0. And if the feature vector x, for every value of x, if it will neither lies on positive side or nor on negative side, it actually lies on the hyperplane, then the equation will be g of x equals to w transpose plus b equals to 0. Then it lies on a hyperplane. Now those equations, what we have written here, all these equations can be said as a classification rule, for which we can compute this equation for every value of feature vector x. So we can call these equations as a classification rule. So now first we have to train the classifier for the classification rule. So how the training is being done? Now we know the equation. In equation, w equals to g of x equals to w transpose into x plus b. That what is w and what is b. So for training the classifier, we use supervised learning. And with the help of large number of samples, actually we required the large numbers of features vectors of two different classes to train the classifier with the help of supervised learning, like some samples for C1 class and some samples for C2 class. So for every training sample we state with the value of what I mean that just a minute. For every training sample we state with the value for the equation w transpose x plus b equals to 0, 0 for C1 class, and again we train all the samples with the help of this equation for class C2, like this is the graph, and this is class C1, and this is class C2, and this line passes from the feature vector of class C1, and this line passes from the feature vector of class C2. So the best separable line in between, it actually divide the width of this space equally between two classes, right? So this is the desirable straight line for classification, and this line is equally apart from class C1 and class C2. So I feel that the best classified if I am far from classification. So what I want to say, if the feature vectors of class C1 is far from this line, so that means it will be safer for the class 1 that it is best separated with C2. And again for C2, if the feature vector, the nearest feature vector of this desired line is far from this line, it means that it is also safer and best separated from the class C2. So just the main motive is to maximize the distance between this and this, so the class C1 and C2 get best separated. If the distance get minimized, then the accuracy will be low. So if we try to increase the separating distance from each class of feature vector, so now what we have to do is, now for xi for class C1, for xi for class C1, we'll write the equation as W transpose xi, where I is 1 to m or 1 to n for all features